Hello, I hope your week 3 is going well. It's Monday, April 20th. We've been in isolation for what, a little over a month now. A little bit crazy. I'm keeping it together mostly. Hardest thing is just getting everything done online. It's kind of painful, isn't it? Well, that's reality. We're stuck with it. This week we are playing with change, which we're getting used to some major change now. The kind of change we're dealing with here is I would characterize as linear change. It's also called like absolute change sometimes. Yeah, you've seen a little bit of it before in the previous math class probably. We're dealing with lines, things that line up for the most part. That is close enough here. Things kind of line up, but they're a little rough, but we kind of smooth them out with a line. So we're going to learn how to do that in there. So just a quick overview of change and some of the things that are happening this week. There's a kind of a overview video for me hidden in lesson 3.4 and in lesson 3.5. So let's just take a quick look there. And so the comparing consumption is probably the harder part of the groups of problems in this set. And so I added an extra video on how I did this problem with a spreadsheet. So this problem doesn't require a spreadsheet. You can do it pencil and paper with a calculator, but feel free to check out this spreadsheet version of the work below here. And then in lesson 3.5, right at the beginning, I have an intro video that's going to go into a little bit more detail than I am right now. So make sure you check those out later. So rates of change, you may have seen before. Another word for a rate of change is slope. And often when I think of slope, I think of my house and I got this roof, and then, I can measure the pitch of the roof by, how high it climbs from the end here and how long it is from here to here. So pitch of a roof is an example. Another example is, you're driving down the road and then, you see this sign as you're driving along, and it says something like 6% grade. Should you be worried about that? What does that mean? So these are a couple of examples of rates of change. Usually with slope in a math class, we talk about a rise and a run. And we have this formula with y's and x's in it. So there's that fun version of it there. Sometimes the slope is, pretty obvious when you're working on a problem. So another example is when I have some free time, I like to mountain bike. And I was playing around in the Blue Mountains last week, and a friend of mine said, hey, there's this really good trail up at the base of Cabbage Hill you should try. He told me how to access it. So I went and checked it out. And I biked for 5 miles. And to bike that 5 miles, it took about, I believe it was 70 minutes. It was a steep climb. And so I might want to calculate my rate of change for this. Right, so what's my change in distance divided by my change in time? And usually we measure in miles per hour. Here I have miles per minute, which is kind of weird. So to clean that up a little bit, I might say, okay, there's definitely 5 miles for my distance. And I'd rather have this in hours. Well, 60 minutes in an hour. So for sure there's 1 hour in there. And then that extra 10 minutes out of 60. So I could say it's 1 10/60 hours, which is going to be a little trouble in my calculator. Let's try it anyway. And my little bicycle computer kind of told me my speed anyway. It was shockingly slow, but let's see what it is here. So bring up a calculator, 2 plus 2. And I want to take that 5 miles and I want to divide. And I'm going to use parentheses because my denominator is kind of complicated. How do you enter a mixed number? The trick is to just type it as you read it. So when I read it, I would say that is 1 and 10 out of 60. And that would be a mixed number on a calculator. Sorry, my keyboard's floppy. There we go. Maybe. And if I hit enter, holy moly, I was going about 4 miles per hour. So I could bike that trail about as fast as somebody could walk if you're doing like, a regular walk on a flat surface. Or if you're a kick butt hiker, you might hike uphill that fast. So it was a long, slow grind uphill, but it was fun and beautiful. So that would be my speed in miles per hour. So speed is a kind of slope. Other times it's a little more complicated. And here I was just given the change. Sometimes you have to do a subtraction to find the changes. So here's an example you're going to come across in your homework. We've got government funding for after-school programs, dollars per child, in 2000, 2010 in the first line. In the second line, we've got cost of offering after-school programs in dollars per child. And what we'll do is we'll look at the change over time, the rate of change of each of these programs. So at first, I think I will ignore the bottom one and just do the top one. So we're just going to draw a line through this one here. We're not going to worry about that one right now. And we're just going to look at this one right here. Some important, wrong button. Some important things about this are identify what the two things are changing. So I have one variable. So I've got time. Time. And time is what we call an independent variable. We don't have much control over. Independent variable. A lot of times we say that's our x variable. And then I have basically money. Dollars per child. And the amount we spent per child depends on the year that we look. In 2000 we spent a lot. In 2010 we didn't spend much. Okay, so this is what we call a dependent variable. Because it depends on the time that we look. And let's call that our y. So this would here would be 0.1 and this here would be 0.2 if I were going to graph them. Okay. So from that formula we're looking at, this is like my x1, x2, and then my y1, y2. But the bottom line, bottom line here is when you're finding slope, it's just the change in whatever you're calling your y value divided by your change in x. Okay, so I've decided that the money is my y values, so I'm going to take the 1800, the second one, and subtract the first one. And you might say, well, I'd rather do 3000 minus 1800. Fine, you could do it that way. Here's the key though. Since I started with 1800 and it goes in 2010, then underneath I have to start with 2010. And then I can go minus 2000 underneath. If you chose to go the other way, if you said, I like doing 3000 better first, cool, you can do that. Minus 1800. But the catch is when you write the numbers down underneath, 3000 has to go with the year 2000. So underneath here goes 2000, and then you go minus 2010. So let's see what happens when we do both of these. So I'm going to whip out my calculator just to be safe. I think the numerator is 1200, but you never know. 3000 minus, what was it, 1800 is 1200. Today's a good day. So my numerator down here, I did the blue one, came out to be a positive 1200. The numerator up here for green, well, that's going to be a negative number, right? Because I have 1800 minus a bigger number, so that's going to be negative 1200. Here I have 2000. Oops, I put the zeros in the wrong spot in both places. Thank you for noticing. Oh, that's a big eraser. That's a little better. Let's clean that up. 2010, not 2100. 2010. Okay, so from 2000 to 2010, 2000 minus a bigger number, that means there's a negative 10 in the bottom there. In the green version up here, I have 2010 minus 2000, bigger number minus smaller one, so that's positive 10. And so either of these, this is a negative over a positive, it's going to have a negative answer. This is a positive over a negative, that'll have a negative answer. So either way, I get an answer here of negative 120. So that means the after-school funding from 2000 to 2010 dropped by about $120 per child per year, right? Because again, what do I have here? The 1,200 is the difference between these two numbers, and those numbers were in dollars. Let's put that in red, maybe. Dollars per child. So that's the numerator. And down here I have years, right? That's a change of 10 years. So we have dollars per child per year. So if I were going to write a sentence for that, and writing sentences is a big part of this course, I would say here that the government funding, I'll abbreviate that, for after-school programs there we go, programs, let's see, it dropped, right, the negative. So instead of writing a negative or saying the word negative, I would say dropped by about $120 per child per year. Would be a sentence describing how we got from here to there in a way that somebody outside of this class would understand. And so the writing principle for this class, remember, is to have an answer so that somebody doesn't have to look back at the question to figure out what the hell you're talking about. So if you just wrote here, hey, the slope is negative 120. Well, negative 120 what? What's the negative mean? What's the 120 mean? So we want to be clear about what it means, which means knowing what each number means here and how to put it all together. That takes a lot of practice. One more quick example, and then I'll shut up and let you guys get some other stuff done. I've been looking at data about COVID-19, and so here I have some data from the Oregon Health Authority that's been collected. On April 11th, I looked, and Baker County had no cases of COVID recorded. That doesn't mean they don't have any. They probably do. And on April 20th, they still had none recorded. Now keep in mind, we have a very poor system of reporting. We have not good access to find out if we have had it or do have it. So for example, I've been sick like 4 times since all this broke out. I could have had COVID-19, but it could have been just a cold or the flu. I don't know. The symptoms overlap enough that it's hard to tell without some intervention. Fortunately, I'm alive and I can still breathe. But notice, things have changed in most counties. I live in Umatilla County. So if I check out Umatilla County, I can see that over the last 9 days, we've gone up. So I'm going to calculate that. So I'm going to make a column here called case change, or change in cases, that would be better. Change in cases. Because these are positive cases, by the way, positive cases, total, right? So like in Clackamas, some of these 116 and 161, they probably don't have it anymore. They've had it, they recovered, or unfortunately possibly died. So for Umatilla County down here, my change would just be the new number, that's like my Y2, minus the old number, that would be my Y1. And we can see here that we've had an increase of 15 cases. Now another thing to consider is we went from 11 to 26. 26 is more than double 11. So in just over a week, the number of cases in my county has more than doubled. It's kind of scary. So I have a change in cases of 15. Now that's not the rate of change though, that's just the numerator. The rate of change also takes into consideration time. So if I wanted to find the rate of change, I would have to divide by the number of days that have gone by. So from the 11th to the 20th, let's say that's 9 days. So the rate of change here would be equal to this rise of 15 cases divided by over 9 days. So what does this number mean? It's positive, right? So that's an increase. All those decimals are kind of painful. Let's drop, oops, wrong one, drop those down a bit. Let's go to 1 decimal place. So these are total cases, was these two numbers. That was my numerator per day, because I divided by the number of days. So in Umatilla County, we have a change of about 1.7 total cases per day. Now, we can't have 1.7 cases in a given day. So the way I would explain that, like if a reporter asked me about it, I would say, well, we've had between 1 and 2 new cases per day in Umatilla County over the last week and a half, closer to 2 cases per day. We've gone from 11 cases to 26 total cases in the 9 days since April 11th. So communicating these things is a little bit complicated, and the more you practice, the better it gets. And that's what we're doing this week, practicing these calculations and trying to explain what they mean to somebody else. I hope this was helpful. I hope your work is going well. Get in touch with me. Say hello. I'll be grading some of your work today and tomorrow. So we'll be in touch. Bye.